I had to make breakfast, and yeah, I don't really have a tripod right now. I'm just beginning to start this live streaming journey of, just typical things like studying and getting on with life. I hope my, well, not I hope, but my goal in live streaming my journey of studying and all that is to keep accountability. Just if someone's watching, then I have to, act accordingly, right? So hopefully that gets me to study more and just be more productive. I hope. Okay, so right, this is where we left off, right? A company is planning to start a data science team. We need a data scientist, and then yeah. When should a company hire a machine learning engineer? Company has developed a new model and wants to incorporate the model into their website. Company has millions of data points, create weekly reports. Machine learning engineer. So machine learning engineer are skilled at applying machine learning models and incorporating those models into existing software or websites. This company should hire a machine learning engineer. Okay, so they're good at incorporating models into software or websites. Okay, so if you already have the model, then that's when you need a machine learning. But if you need to create the model, then that's when you need a data analyst, right? Because you want to create a weekly report of plots of customer interactions, stuff like that. Okay. Let's see here. Now, see here. Oh, Lord have mercy. We have not even begun scratching the roof of this progress. Anyways, collecting patient records and tumor scans from hospitals. If you're collecting, you're gathering, so that's pretty common sense. Make a plot of blood work results, and tumor type. So you make a plot, right? That's exploring data by making a plot because you've collected the records and the scans, right? So you're making the plot by exploring data. I don't really know how that's exploring. If exploring means like you're looking. Anyways, remove missing, cleaning data, right? That's pretty common sense. Give a presentation at a conference on how to use the model to treat patients. Well, that's out. Like my first instinct would be modeling data because you're like modeling, but modeling is to test and evaluate several models for predicting tumor type. Hello, 10 viewers. Anybody commented? Hi, Nicole. Nice to meet you. Hope you are studying as well. It's exam season, so continue studying with me or watching me study. This is on data science. So interpreting data, that's when you give presentation at a conference on how to use a model to treat patients, right? Because you're interpreting what that data means. You're sending that message out there. Modeling data, what's a model, right? No best model exists, but data scientists must use content knowledge and modeling skills to determine a reasonable choice. Oh, everyone's bored and left. I shouldn't be deterred by that though. Which of the following data set is structured? Written product reviews, customer mailing address, images of products on a website. Okay. Now, structured means that it can be stored in a table with rows for each customer and columns for street address, city, state, and zip code. So you can't really, make a row and column chart with written product reviews. You could see the reviews, but you can't make a chart, right? A table. Images of products on a website. That's useful, but it's not something that you could make a data set, right? You can't really structure it. So which of the following data sets is unstructured? I think these two, like written product reviews and images, are unstructured, right? But in this case, book genres, I think you could make a data chart with that, right? Because you have a lot of genres, right? Like you could make like different columns, at least a row of those. Library records, historical letters. Hmm. Well, this is hard because historical letters, you could, make a row out of how old each one is, but it's still considered unstructured because texts like journals, books, or letters do not have a single consistent format. I mean, time is a consistent format, right? I guess not every historical letter you can tell the time of, what age it came from. That's confusing, but, you know, book genres, library records, they're easier to tell when, you can structure them or not. Historical letters, not so much. So which of the following datasets is semi-structured? So it's between structured and unstructured, right? A table on Wikipedia of weekly box office sales for major movie releases. That's I mean, that's pretty shocking to me. That's semi-structured because it's still a table, right? And it's a weekly thing, and there's sales. But let's see about the other ones. Video clips from movie trailers. That's definitely unstructured. Weekly box office sales for major movie releases. Okay, that's what I was thinking the first one meant. But this is structured. Okay, this is semi-structured. Because why is it semi-structured? Because Wikipedia is not a reliable source, right? So online tables are usually in XML or JSON format. Online tables contain visual styling elements as well as the dataset, which makes the data semi-structured. Let's read that again because I did not understand that. Online tables are usually in those two formats. Online tables contain visual styling elements as well as the dataset. Primo, I sort of remember you. I don't remember like anything about you. Oh yeah, you. Oh, okay, yeah. I'm starting to remember. Yeah, yeah, I remember. You were in class, and I was like bored. Okay, nice to see you again. Today we are studying, so hopefully your teacher um is not so strict. I don't know anymore. Nice to see you again, actually. Like that's pretty cool. We have a returning viewer here. Okay, so cleaning data. I think this concept is pretty easy because it's just like removing empty, you know, uh, data sets in the, empty spaces in the data set. So, Why is why is clean data important in a data science project? Because clean data contains all possible features. No, there's missing data, right? Not that. It's free of errors. I wouldn't say that because if you have a missing data set, it could be missing something important. So that increases chances of errors, right? So clean datasets are formatted for building models and creating visualizations. Yeah, that makes more sense because models, that's the only reason you have like linear regression and stuff. I'm on my off day. Very nice. Hope you enjoy your off day. It's nice that you're watching this live stream on your off day as well because it's still, you know, something that, yeah, it's not something you do for fun to study, but let's see why clean datasets are formatted for building models and creating visualizations. So most software packages and programming languages such as Python or R require datasets to be structured. Algorithms and graphing functions assume that rows containing instances and columns contain features. Okay, so yeah, Rows contain instances and columns contain features. Rows contain instances, features. Okay, that makes sense. A data scientist is developing a model to classify tumors as benign or malignant based on patient records, blood work, and image data. Bro, sorry, I don't know what you're learning about, so I can't help. It's nice of you to even want to help. I'm just going over certain questions that are for sure going to be on the exam, but it's not all of the questions, so we have to go over all of the questions. So, what should the data scientist do with patients who have missing data? Who have missing data? Remove the patient with missing values from the dataset. No, you still need to help your patients. You can't remove the whole patient, right? Ignore the missing values. That's also dangerous. Investigate why patients have missing values. Okay, that's pretty simple. A patient has a missing value for certain blood tests because the test has not been given. Okay, pretty straightforward. I think I am understanding these questions. So, hi, I'm new. Nice to meet you, Kaden. Welcome to the live stream. Hello. Today we are studying data science. If you need anything to study, you could study alongside me. So, you know, this is an accountability channel basically. You need to be accountable for your studying. So, I have a hard time being accountable for my studying. I have a midterm on Monday, right? And it's Friday. So, yeah. Hopefully all this accountability live streaming stuff was actually going to help me. I'm planning to get through all of the questions today and then go over coding tomorrow. So, yeah, that's the plan. So, data science uses exploratory data analysis to recognize patterns and relationships, look for errors, make predictions. Exploratory data. Well, I would guess that it's about making predictions because that's what all this is about, right? But you sort of have to do that after you recognize patterns in relationships. So let's see why this is the right answer, right? Recognizing patterns and relationships between features in a dataset. Graphs and plots help data scientists recognize patterns or describe relationships between features. For example, in the previous animation, the data scientists noticed that Adelie penguins have shorter bills by examining the box plot. So that's what exploratory data analysis is used for. I forgot. I wish to learn about the stuff you have to do on Monday. Wish me luck. Really? You're interested in data science? That's pretty cool. Hopefully you learn. It's yeah, it's pretty confusing honestly. Like I don't really uh, unless the questions are exactly the same, I don't know if I'm gonna do good on the exam, but hopefully we'll see. We're gonna use Scantron, so that should be that should make the test easier, I'd say, because it's multiple choice. At least I don't have to write down the answers. So how many features are included in the scatter plot above? Oh, right. So features are the like we went over, right? They were the rows, and instances are the columns. Don't worry, you'll go great. Thank you, thank you. I hope you do good in all your future exams as well. So, right, let's see about the rows. One, two, three, four, five. No, wait. Rows? It's only one row. Wait, how many features are included in the scatter plot? Well, these are the features, yeah, but I was thinking like rows and columns, but this is not a table, right? This is a graph, so yeah, it makes sense that there'd be three. Because if you said what about the instances, you think about how many dots there are, right? So yeah, three makes sense here. So use color and shape to mark species in addition to bill length and depth on the axes. Okay, that makes sense. Modeling data. So which scenario is appropriate for a classification model? predicting the sales, predicting whether a house will sell, and predicting how many days a house will be on the market. So appropriate for classification models. So the sale price. Well, okay. So my reasoning for why the second one would be right is because you know you can't really say yes or no to the first or the third one, but you can say yes or no to predicting whether a house will sell in under 30 days or not. Because if it does, it's yes. If it doesn't, then it's no. Right? So that's the classification, right? You have to do this stuff in grade 4? Oh wow. Yeah. I can see a lot of the stuff that I do like in these hard classes that I've done in 4th grade. Like median mode. Like you're just gonna see it over and over again. And the way they go so in deep with it. Wait, you're in 4th grade? That's crazy. I don't know why I'm getting a lot of young viewers. But I just hope you're safe online, right? Because when you're younger, I mean, not to judge you or anything. Okay, yeah, stay safe. Whether or not a house sells in under 30 days is categorical. Yeah, exactly. That was my reasoning for it. Okay, so which scenario is appropriate for unsupervised model? So you're not looking at it all the time, right? So grouping major cities based on weather patterns, predicting average rainfall in major cities, predicting high temperatures in major cities. Hmm. Now this is hard because honestly, what does undersupervised even mean, right? Like you're supposed to read before you answer the questions, but yeah, I like to do the questions and then find the reasoning why. Just guessing because that's what I do on an exam normally. So grouping major cities based on weather patterns. Well, that makes sense because you don't have to look at the cities 24/7, right? You could tell weather patterns by, historical records from before, so you could group that. Predicting average rainfall, it changes every year, right? And high temperatures in major cities, that also changes. Um, I don't know. I don't know. Let's see the answer. Unsupervised models look for hidden groups or relationships in a data set. Grouping major cities together may reveal a pattern or trend that major cities share. Hidden groups or relationships. You like to learn about space? That's very nice. Hello, Dio Brando. Welcome to the stream. We are studying data science, and I am very happy that a lot of young people are interested in this stuff. Like that. That's crazy to me because you know, yeah, everyone's into brain rot, but it's good that you're learning something online, right? So let's look here. Which scenario is appropriate for unsupervised model? I already went over this question, but what are some hidden like relationships, right? Group major cities based on weather patterns. Hidden groups or relationships. So grouping major cities together may reveal a pattern or trend that major cities share. Okay, I think I'll just go to the next question. So which scenario is appropriate for a regression model? Predicting whether a flight will be delayed, predicting the length of a flight, predicting the cause of a flight delay. Your favorite planet is J104b and Tom 16. Wow, you actually know a lot of stuff. I'm I'm surprised because I don't even know these planet names. So tell me why you like those two planets while I study. So the length. Okay, the scenario is appropriate for regression model, predicting whether a flight will be delayed. You can't really put that in a graph, right? Like you say, a flight will be delayed like what are you gonna put on the column if you have the time for the you know the rows? So predicting the cause of flight delay. Hmm, I guess you could put it on a graph, but the length makes the most sense that you put on a regression model, right? Because regression model looks like the last um the last one we saw with the three features. So regression models are used to predict numerical variables such as the length, 10 minutes, 15 minutes, etc. Yeah, that makes sense. This message, because Tom 16 is the biggest black hole known to mankind. Wow. That is, you're teaching me while I'm teaching you. That's yeah, that's great. Biggest black hole known to mankind. Honestly, black holes are really interesting. They defy every law, or not every, but like the laws of physics that we know, right? Like we think that okay, we could learn something, we could be sure of something, but you realize you can't be sure of anything because those laws get defied. It's crazy. And I heard like when you go near a black hole, time literally stops. It's bigger than the universe. Whoa, wow, that's I don't even know how to grasp that concept because it's in the universe, right? So how's it bigger than the universe? Well, I guess you can't really measure how big it is on the inside, right? Have you watched Interstellar? I love that movie, bro. A data scientist developed a model to classify tumors in benign or malignant based on the patient records. The model is highly accurate, and other data scientists and clinicians are interested in the result. How would a data scientist communicate their findings to each group? So short and non-technical presentation, technical report with code, presentation with application using patient data. So for hospital or clinic administrators, administrators at hospital or clinic might hear about the model and want to know more. However, administrators are probably not interested in the model's technical details. So I guess you have to keep it like short, right? That makes sense. But data scientists are nerdy, so you have to be more technical with it. And clinicians treating patients based on the model. So presentation with application using patient data. Okay, so applications make sense because you have to teach them, right? I'm not sure if application means like their forms or like application with like applying certain ways to, help the patient. Hmm. Yeah. Tom 16 is bigger than our galaxy. Oh, okay, that makes sense. Yeah, because the Milky Way is pretty. It's like one galaxy. There's like so many other galaxies. Like there's definitely a galaxy like out there that's bigger than ours, right? So it makes sense if a black hole is bigger than that too. That's pretty crazy though. I mean, you'd think like you know, if you see the sun, how big it is, you'd think that it's like the biggest thing ever. But then the universe is even bigger. So there just has to be a creator. Like, do you believe in God? Because I don't know any explanation for our whole existence and being to even be possible without someone greater than us. And J14b has the most rings, at least 600 times bigger than Saturn. Whoa. Ring has the most rings? How many rings? I thought Saturn only has one ring. Had, wait, let me see 104b. Planet? Whoa. This is so cool. Let's see. How? I'm trying not to use both hands so I don't cover the screen, but how many rings? Wait, J104, Super Saturn. 30 rings? No way. This is actually insane. I've never seen something like this. You know what this looks like? It looks like those, Mario Kart maps where you just go in circles. Not circles, but like in those curves. Like, looks like Rainbow Road. Honestly, I get emotional looking at these pictures because it's just so amazing. The Black Planet. Wow, wow, wow. So beautiful. Planet 9 is a black hole. Whoa. I can see why you're interested in stuff. It's so interesting too. And the way how it's so much bigger than us, it's crazy. Like you wish that you're bigger so you could see it more easily. Alright, back to studying. We did this, we did this, we did this. Okay, okay. Let's see. Data science lifecycle. A data scientist for an online retailer is given the assignment of predicting what a customer will be interested on past purchases. So, what task does the data scientist do next? Predicting what a customer will be interested. Well, he hasn't started anything. He was just given that assignment, right? So, I'd say like it's expected that he obtains a data set for characteristics and you know purchases for a sample of customers. So, yeah, gathering the data is crucial first, so then you can make predictions and then yeah, all that jazz. So why is ethical conduct an essential part of data science? Oh, because these large volumes must follow legal restrictions. I would be tempted to answer this one, but yeah, they are definitely using personal data, so that makes sense why it's more essential to conduct conduct their stuff ethically. Often work with datasets containing personal information such as age, gender, address, credit card numbers. Personal information can be used to steal a person's identity or to discriminate against someone. Whoa. Human nature, man. That's the only reason we need ethics in our life. Type Tom 16 compared to Earth if you have time. Okay, let's see. Tom 16 compared to Earth. Based on your query, Tom 16 likely refers to Tom as J. Yeah, that one. Star system containing a super Earth exoplanet. A comparison of the system's exoplanet to Earth reveals notable differences in its mass and density. Whoa. Hmm. So Earth is rocky and terrestrial planet orbiting a G-type main sequence star, our sun. Super Earth exoplanet orbiting a low mass star. I guess that's why it's not like it's not habitable because it's such a super Earth. Like there's a low mass star that it's orbiting. You need a G type or like a main sequence star to sustain life, right? You know the stuff. Then you're learning about is sick. Yeah, I know, right? Because it's kind of a lot about data science. I'm more interested in what you're learning about. That's crazy how you know so much about planets and stuff. You read books or you just Google it and then explain it that way. So, what type of personal data is protected by HIPAA? HIPAA. Hmm. I would assume H stands for health or something, but because like it's yeah. So health data. HIPAA 1996 regulates how personal data in healthcare is shared by providers and protected from fraud. Okay. H for HIPAA. I mean HIPAA health for H and HIPAA. The U.S. Census Bureau released a public dataset following each census and survey conducted. The Census Bureau estimates that a majority of Americans can be uniquely identified using census data. So the Census Bureau protects individual information by anonymizing data sets before public release. So which of the following changes is an example of data shifting? Changing the annual wage by a small amount, such as $1,000. Grouping related jobs into a larger category, removing wages from this public data set. So when you're shifting data, I mean, grouping is different from shifting, right? Because, you know, they're still together, I guess. I mean, the data is still protected. Like, you're not really shifting data, right? Removing wages from the public data set. Yeah. Data shifting applies a small change to a numerical variable. Okay, so that's why this one makes more sense, right? Because that's the numerical variable here that you're shifting. So you read books and watch YouTube. That is so. I'd be so proud of you. Hey Miriam, or not Miriam, Isa. Nice to see you again. We're studying today. I can't believe I've been doing this for half an hour. It felt like so much longer, bro. The sun went down. Okay. Which of the following changes is an example of data grouping? So what is data grouping? Let me see. Changing the age by 1 to 2 years. No, that's data shifting. Swapping features between two data points. Uh, does not sound like grouping. Combining years. Okay, combining is definitely grouping. Of school completed into less than a high school degree, or some college. Okay, so yeah, third one makes sense. Grouping or combining years of school completed into large categories makes the individual respondents more difficult to identify. Okay, so according to researchers at the Census Bureau about how many Americans could be uniquely identified from census data without about how many Americans could be uniquely identified from census data without anonymizing. About 60%. Whoa. Okay. 2016 Census Bureau researchers estimate about 58% of Americans could be uniquely identified in the non-anonymized census data using data from commercial databases. Okay, because if it's not anonymized, then it has to be the highest degree, right? The highest percentage. So 60% makes more sense. Uh, wait. Right, the left. Bro, I'm gonna go study about more space. You never know what stuff there is in space. Alright, have fun. And I'm really proud of you for studying. That's a very good thing that you're doing. And never stop, okay? Have a good rest of your day. Primo. And yeah, I'll be here if you wanna come back to watch me study. So 60% makes more sense. Let's see. In 2020, face that looks so blah blah blah. Who's the figure in the pixelated image? Obama, obviously. This was not an isolated incident. Several famous people were misgendered, misidentified, or both using the software. What is the likely cause? The image of Asian, Black, Hispanics, and other underrepresented groups were low resolution. The model's developers were biased.
Models were trained using images of primarily white people. That's crazy. Because they do look alike, but he was definitely not white. So, yeah, the model was trained using over 70,000 images, which were primarily photos of white people. This bias in the data resulted in biased model outputs. The model's developers were biased. Okay, so the developers were not biased, but they did use 70,000 images to train the model. So that's the reason. So it's not the developer's fault, is because it was trained that way. Um, yeah. Okay, so the pixelizers result for the image above was a white male, appearing to be in his 40s. Is this an example of algorithmic bias? How's it an algorithmic bias if it was trained to do that? I guess it is. Okay, so the algorithm's input was widely recognizable. Okay, black man. Yeah, yeah, yeah. So the input was a black man, the output was white. So I guess it was an algorithmic bias, just because it was trained that way. Isa, where are you going? Where'd you say bye? What's that? What's what? This thing? This thing that I'm doing? They're just screenshots of the answers of the questions I did, so I know like what I'm studying basically. Cause I ain't reading. You know, my worst I mean, my least favorite thing to do is to read, which is sad. So I'm very proud of anyone who likes reading. I hope it, you learn a lot of things and it sticks to you. But for some reason, when I read, it doesn't stick to me. So it just seems like a waste of time. But this is not a waste of time if you go over the important stuff. So Cambridge and now Analytica's practices were discovered in 2018. Blah blah blah. Cambridge Analytica's combined psychological profiles and blank data to customize ads for users. I guess I should have read this, but I don't want to read so much. Shush, Primo. Hey, don't be rude to Primo. He's actually so smart. I have very high hopes for him because he reads books and stuff. So, yeah. Hello. Oh, I'm so bored. I hate studying. Do you study, Isa? think I wanna think I wanna eat. Back. I learned a new planet, Quaster. Look up the sound that it makes. Quaster. Let's see. Oh my gosh. No way. Forgot to read, so it's like have today. Quaster sound. Quasar. Dang, that sounds like a fan. But I'm sure it's really scary, like, and really loud. Maybe our eardrums could not handle it, so yeah. Sounds like a helicopter almost. I'm curious to know what this is. Hey, look at that. I got 2 subscribers. Nice. Okay, back to studying. I had a little short break there. Okay, so Cambridge Analytica's combines psychological profiles and linked data to customize ads for users. Location, voter, party affiliation. Okay, location makes sense because voter registration and party affiliation doesn't have to do that much with a person. I mean, I guess it does, but that doesn't say as much as you'd want because not everyone is political, right? So locations definitely uh something to utilize for customizing ads for users. So Facebook users often list their current city on their Facebook profiles. Cambridge Analytica was able to use this information to target ads for local elections too. Okay, okay. So Facebook's stock decreased in values by 24% in the immediate wake of the scandal. Did Facebook face any further penalties for their involvement? Scandal. Oh, Facebook is scandalous. No, Facebook did not. Facebook paid millions in fines. Billions? That's crazy. The FTC fined Facebook nearly $5 billion for misuse of user data. Oh my god, if I had $5 billion, I don't know what I'd do. You gonna take a nap? Okay. Have a good nap. Okay? When you wake up, you could go back to studying your planet and stuff. All that jazz. That's not the only coaster. That's not the only one that it makes. Okay. We can go over more if you're still here, but you should go take a nap. Yeah. I'll take a nap too. This was super boring. So $5 billion for misuse of user data. $100 million to the SEC for misleading investors, and $725 million to users. How come I didn't get that money? I guess I don't use Facebook, but I mean, Instagram does count. Okay. Data centers use energy for storing data via servers, cooling systems, infrastructure, and communications. Together, the servers and cooling systems use about 80% of energy consumed by data centers. Wow. 80% of energy? It's crazy. So globally, how much energy do data centers use? About 1%. It doesn't seem like much, but 1% of the global energy is pretty crazy. I don't know what all the other ones go. Where all the other ones are used for. Okay, so how much energy at a data center is used by the servers? How much energy at a data center is used by the servers? 40%. Huh. Okay, yeah, that makes sense because data center is the main thing that you're using, right? How much energy at a data center is used by the cooling systems? Also 40%. Let's see what. So data centers store the data on large computers called servers. Servers use about 40% of energy at data centers. Okay, so the servers use 40% of energy, and the data centers contain those servers, which are large computers. Okay, so that's 40% of where the energy in the data center goes. And then the other 40%, or well, there is 60% left, but if it uses 80% of energy, then 40% is left. So the only answer is 40% here because it goes to the cooling system. You need a cooling system and also the servers, right? You have two equal portions, and each of them take half of the amount of energy that is being consumed by the data centers, which is 80%. Oh my god. Let's see. How many we have left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 10, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36, I think. Okay, it's tempting to just start from the bottom and going up till you see where I stop, but we gotta do this all one by one. Right? I remember that Obama face. Alright. I think I'm gonna do like 5 more, and then we're gonna stop there, continue on later. I'll continue today, but I need to pray and eat and stuff. 5 more. 5 more. I got 5 more in me. So Sign Match predicted that a customer would rate Titanic 1997 3.2 stars. That's pretty low. Honestly, I like Titanic. Customer watched Titanic and rated the movie 3 stars. Find the prediction error. Well, 0.2, right? Because, yeah, 3.2 minus 3 is 0.2. Sign Match accurately predicted the customer's movie rating within 0.5 stars 75% of the time. How often did Sign Match fail to predict a customer's rating within 0.5 stars? So, okay, accurately predicted 75% of the time. So the only percentage left is 25%. So that makes sense. Okay, 4 more. I trying to, yeah. Finding Netflix users were included in the Netflix prize data set. Maybe there was like a diagram or something, like a visual to tell. Let's see in the participation activity. 1.6. 1.2. Let's go down here to 1.6 here. Wait, I don't know why I did that. Okay. The Netflix prize data set. Bro, this is pretty hard. How many Netflix users were included in the Netflix prize data set? Let's look for users here. Does not occur to me where the population is. But I'd say maybe this might be the population and this might be the year and then the name. Wait. Oh, this part is important. Okay. Okay, so it says here the user amount. Okay. That makes sense. Yeah, for this and then this set Netflix provided to competing teams were to competing teams. It's structured, right? Because it says structured data set right there. Ah, Oh my god, it's not structured, bro. To competing teams. Oh my god, how do you even tell? See, this is why I use those screenshots instead of this. Oh my god, bruh. What are you watching this for? Also, do my laundry, okay? This live stream is only for accountability purposes, so that's why I'm doing this, right? So that I could, you know, when people watch it, then I have to study, right? So let's see why it's not structured, or if it's unstructured or structured. Mm, so structured data is in table form. However, the data sets originally provided by Netflix were not in tables. Originally provided. So the data sets Netflix provided were not structured. You had to make them structured, right? So it's unstructured. I guess the data sets provided by Netflix were text files with features in data separated by a comma. Did you play Muggin? I have to, yes. I thought I'd do like 5 more. That's why I'm getting everything wrong. So it's semi structured because it's not completely structured, but it has 2 text files, right? And it had different formats, but it's consistent non-table format, which made the data set semi-structured. Okay, okay. So, how long did Netflix prize competition last? The prize competition. Hmm. Mm, 20 years. Several years passed. 10% improvement. 29. 30-day window. Okay, if it says several, then I guess you have to guess based on the word several, right? It's like 3 years? Yeah! Okay, so it launched out 2006. Did it say here anything about 2006? Nope. Just 2009. Okay, so final submission deadline was 2009 and the winning team was announced September 18th. Okay, so which team won the Netflix prize? Let's see. Netflix prize results, quiz data. I'd say this team, right? Because it has a higher quiz data. I don't know though. A team called Belcore's Pragmatic Chaos submitted a model that met Netflix's goal. Submission started 30 days, and some was 20 minutes late. Okay, so the Belcore Pragmatic Chaos one. Let's see here. Yes, yes. Okay. The winning algorithm. Alright, I think we're almost done. We have 1.6.8, 1.6.9, and also 1.6.10. Okay, we have 3 more, and then we're gonna end the stream and call it a day. Actually, no, I'm gonna continue after this and do the second chapter right here. Okay, so the algorithm developed by Belcore's Pragmatic Chaos was eventually used on Netflix's website. Did they though? Let's see, let's see. What Netflix evaluated predictions, but was never used. Wow, never used. See, reading is very important because you'd think they used the algorithm, but because they won, but no, they didn't. Okay, so all right, so users included in the competition dataset could have been identified. I think data ownership, what? Privacy? Would not without ethical usage. Match the ethical concern with the aspect of the competition. Could have been identified. I think privacy. Okay, user did not consent. Yeah. Alright. User included in the competition dataset may not reflect. Well, there's only one left, but you have to see what bias means, right? User included in the competition datasets may not have reflected all Netflix users. You need to include all of them, not just some. That's biased. Alright, I think that's all. It's good, right? Can't scroll down anymore. Oh, now I can. Alright. We're gonna start chapter 2 later after a short break. And yeah, that concludes